How does matrix transform a square? 0, 1, 1, 1. This is 1. This is 0. This 1. And then this 0. 1. Here y is 0. Here x is 0. Y is 1. Y. Sorry. Y. Here x. That's why we have formed square. 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 So formed square. 0, 1, 1, 0. Formed square. Matrix transform a square. Matrix 0, 1, 1, 0. Square. Transform. Transform. Okay. How does matrix transform a square? 0, 3 to 1. 0, 2. 0, 2. X1, X2. This is X1. You can say this is X1, this is X2. So next, sorry. 0, 0, 2. This 0, this 0, 2. This 3, 1 here. Up to 3, this one. 1 here. 1. This 0 here. This 0. These 2 up to here. These 3 up to here. This 1 up to here. So now mad square. Okay. Mad square. Perfectly. Sorry for area. Area. What is this asking? Geometry definition of the determinant. Geometry definition of the determinant. From this determinant, what is the geometry definition? How does matrix transform a square? How it is possible? Area. Area equal to mod of determinant of matrix. Mod. So determinant of matrix A, B, C, D element. So cross multiplication. Cross multiplication AD minus CB. Sorry, minus BC mod. That's why on that side. Okay. Example, solve the algebraic equation. This is the algebraic equation. Ax equal to lambda x. Solve this. Ah, solve this. Solve the algebraic equation. Example, Ax equal to lambda x. Ax vector equal to lambda x vector. So A equal to what formula? A equal to minus lambda 1. This one we have to x only will keep here. So if x, how it will go? So then it will go in there. No, x is the common. No, so both are bring together. Then 0 will come. Then a a ax minus lambda x. So what will happen? Take common x, then a lambda 1. If you put 1 is 1 only always. So determinant of a minus lambda 1. So what will happen? 0 or x bar equal to 0, s vector also. Example of an undetermined underdetermined system. Example of an underdetermined system. Underdetermined of system. This is underdetermined of the system. So do multiplication x1 minus like this and like x1 minus x2 equal to 0 2 x1 minus 2 x2. So this one and this 2x1 minus 2x2. So got it. Okay, 0. Then add everything. So x1 x minus x2, then it will come 2x1. So 2 cancel. After that, so x1 equal to x2. Some non-zero x are sent to 0. Some non-zero x are sent to 0. The set of all x is mx equal to 0 are called the null space of M. Mx equal to 0 are called the null space of M. This is because determinant of M equal to 0. M is not invertible. M you can't able to invertible. If determinant M is not 0, M determinant also not 0. The only solution is x equal to 0. That's why x is equal to 0. Undetermined system. Example. Eigenvector, eigenvalue. What do mean? What do matrix two vectors? To do vector. what to what do matrix to do vectors 0 3 2 1 element into 2 1. Matrix what we have to do for vectors, make vectors. So 0 2, take this here, this 0. This 3 1, 3 1. This 2 1 result. So 0 2, 0 2 y 2. Yes, 3 x 1 y, like this 2 x y 1. This is y axis, this is x axis. So what will happen? Recall 0 3, okay, 0 3 2 1 2 1. So take common this one 2 element, this 0 2, then plus, then this one here 3 1, then here, then add 2 0 2 2 4 1 3 1 1. So 0 plus 3 0 plus 3 3 4 plus 1 5. So 3 5 is the output. So 3 5 3, this 3 5 here. So 3 in x axis, 5 in y axis. The new vector is rotated scaled. We can able to rotate, we can able to do scaling. Are there, sorry, are there any special vectors that only get scaled? Any special vectors? Are there any special vectors that only get scaled? Only we have to get the scaled only. How? Try 1 comma 1. Okay, this 1 comma 1. Yes, yes, bar. So 1 here 1 will come. Here also 1 will come. So this 0 2 here. This 3 1 here. So 1 same value, 1 here multiplied by same value. So 0 plus 3 3. 2 plus 1 3. So 3 comma 3. So this one same, no? Only extension. 3. Vector. Are there any special vectors that only get scaled? So 3 by 3 means what? Scaling only.